Howdy and good day. We are in Algebra, continuing our journey through PO10. Yesterday we focused on combining like terms and the distributive property. We're going to correct that work, and then today get into variables on both sides to wrap up phase one of the year before MEA break. So starting with this, negative 20 equals negative 4x minus 6x. This is one of the ones you needed to do. Opposite operations. Let me turn on my smart ink there. Opposite operations is the method. Sorry. We would not use opposite operations here because they are on the same side of the equal sign. We're not moving anything. We are just combining. So negative 4x's minus 6x's, that gives us a total of negative 10x's. You only use opposite operations when you're moving something from one side of the equation to the other.
Lord. It's like scribbling and erasing.
Where's your homework?
Do you have your binder?
Oh yeah, I have my binder.
Oh,
I just did the word. Did you do the 100 question sheet we have?
Shh. Divide both sides by negative 10 to get x by itself, and x equals 2. Okay, so pretty standard combining like terms method there. The next one, same kind of thing, only this time dealing with constants. We've got positive 1 and a positive 5. Together, those give us positive 6. So whether you write this as 6 equals negative 2n plus 6, or 6 equals 6 minus 2n, as we've seen with the 5-card challenge in the math packets, you know, both of these expressions here have a negative 2n and a positive 6. Okay, they're reversed, but the signs are the same, therefore it means the same thing. And as you noticed, regardless of which way you wrote it, you should get n to equal 0 when you're done. Okay, so for that one, n equals 0. Questions on those first two? Okay, moving on then, down to this one, 24 equals 5p plus 3p minus 8. Again, combine the like terms, not using opposite operations because we're not moving them from one side to the other. We get 24 equals 8p minus 8. There's our two-step equation. So we'd add 8 to both sides. 32 equals 8 times p, divide by 8, and we get a value of 4. Easy peasy, Zach Parisi. Okay, for you hockey fans. The next one I had you do was next row down. Now we start to practice the distributive property, right? And we know that we're going to be using this because we see those parentheses. What are we distributing in to that set of parentheses? McKenna? A negative 1, right? That 10, you wouldn't read that as 10 times x plus 4, right? It's 10 minus, then in parentheses, x plus 4. So we're not going to put in the 10 because we're not multiplying the parentheses by 10. It's that hidden negative 1, okay, that's there even though it's not really written. Just the negative sign is. So we're going to distribute that in, and all that really does is it changes the sign of what we have inside of our parentheses. So negative 8 equals 10 minus x minus 4. Combined like terms, our constants, 10 and a negative 4 combined to be a positive 6. 10 minus 4 is positive 6. Now we're going to be using opposite operations forgot to put my negative sign there, to move that 6 over to the other side. Okay, so what's that? No, yeah. Subtract 6 from both sides, we get negative 14 equals negative x, but we're not done yet. Because what is that coefficient to x? Lily? Negative 1. Okay? Negative 1x. So our final step would be to divide both sides by negative 1, get x by itself, and it turns out that we have a positive 14 equals x. Positive 14. Okay? Questions on that one? All right. Then we have, what do we use? Just the bottom row left? Yeah. These three here. That first one, we're distributing in the negative 4. So we get 20 equals negative 64. Negative 4 times 16 minus 12. Okay. Two-step equation. We're going to start by adding 12 to both sides. 32 equals negative 64x. Divide both sides by negative 64. And negative 1/2 is your answer. Negative 1/2. If you wrote that as negative 0.5, that's okay. Okay. But negative 1/2. Next one, we're distributing in the 6. 6 times p and 6 times negative 8. So 12 equals 6p minus 48. Again, just watch that sign. Okay, it is 6 times negative 8. Add 48 to both sides. 60 equals 6 times p. Divide both sides by 6. And we get 10. Get 10. And the last one in this row, distributing in the negative 4, gives us negative 4 times 7, negative 28, plus 20x, negative 4 times that negative 5, right? Include both signs there. Positive 20x, and that equals 12. Two-step equation, start that constant. The opposite of a negative 28 is positive, so we're going to add 28 to both sides. Cancel it out there. We get 20x equals 40. Divide both sides by 20. And x equals 2. X equals 2. Any questions on that? There weren't any entered in on the Google question form, so I did check that and nothing contributed there. Okay. Algebra, as you've seen, because you've done these types of equations before, and as you will see going forward, it's a very, very detailed type of math in that negative signs really come into play. And the advantage of showing your work, showing every single step, is not only is it easier to find a mistake, should you make one, right? But it's also less likely that you're going to make one because you're writing everything out and you're verifying things as you go along. So showing that work is valuable. Are we ready for variables on both sides?
Yeah.
Don't be scared. Don't be scared. No. Okay. So I understand from RK that you've had this before, Matthew. Do you have a question? Yes. So you've dabbled in variables on both sides equations before, yes? Okay. So then you'll probably remember that the goal of variables on both sides, just like combining like terms and just like the distributive property, is that we want to get that two-step equation. Okay. Only for variables on both sides, we want to move the variables to one side. We want to get them on the same side to get ourselves a two-step equation. Okay. We want to move the variables to one side to get ourselves a two-step equation. So this is just another type of multi-step equation that you might see. All right. So let's look at this first one here. 16x minus 5 equals 12x plus 23. Think back to last year, whenever you've seen these before. What are your options? Because you've got a couple. What are your options for moving those variables to one side? Nick?
This is subtract the 12x over to the other side.
Sure. Okay. If our goal here is to move all the x's or all the variables to one side, we can say, well, I've got 16 on the left side, 12 on the right side. I'm going to take these 12 x's and move them to the other side. And because we're moving them, we're using opposite operations here. I'm subtracting 12x from both sides because 12 minus 12 is 0. There are no more x's there. I've moved them all over. Okay. And now I've got 16 minus 12x, which is 4x, minus 5 equals 23. There's my two-step equation right there. Okay. Now, if you're thinking, well, why aren't I dividing here, right? Because usually when you've got, variable terms, 10x equals 40, you divide both sides by 10, to solve it. Why are we using subtraction here instead of division? Why is this different from how we've used variables in the past with coefficients? Sebastian.
This because we have variables on both sides, so instead of having to do the opposites, you're supposed to do it so that you can get the both sides equal.
Okay, we are using opposite operations, but we're focusing on the whole 12x rather than just the 10, right? Luke, what are you going to say?
Because when you're doing that, you're turning that in, you're taking away the x from it. And if you did that over the 16, it would be 16x divided by 10.
Sure. Yeah. The goal here in 10x equals 40 is to separate the x from the coefficient. We want the x to stay on the left side. We want to move the 10 over, right? We want the x to stay. We're separating. Here, we're taking all 12 x's. Let's say x is equal to tacos, right? You've got 12 of them. You take all 12 of those tacos and you move them to the other side of the equation so there are no tacos left on the right side. Okay, so we're using subtraction here to move all of the x's. The x is moving too. Another option that we have here, 16x minus 5 equals 12x plus 23, would be to what? Nick said to subtract 12x from both sides to move all of our x's over to the left side. Could you move them to the right side? You can. Okay, you can. You could subtract 16 x's from both sides to get them to cancel out on the left, and you'd have negative 5 equals negative 4x plus 23. At this point, our two equations that we have here are exactly the same, except for the location of the x's. If you move them left, the 4x is positive. If you move them to the right side, you say negative 4x. But it doesn't matter because we'll get the same answer when all is said and done. Here, we would add 5. 4x equals 28. Divide by 4, x is 7. Over here, we'd subtract 23. So negative 28 equals negative 4x. Divide both sides by negative 4. And a negative 28 divided by negative 4 is a positive 7. So it does not matter which side you move the variables to. Most students prefer to keep that coefficient positive. So they'll look for which side do I move them to keep that positive. Okay? But it really doesn't matter. Another way to think about this is to almost think about it like the score of a basketball game, right? 16 to 12. We have 16 x's on the left, 12 x's on the right. Isn't being ahead in a basketball game 16 to 12 really the same as being ahead 4 to 0? I mean, if the difference is 4 points, does it really matter what those numbers are? No, you're up by 4. Doesn't really make a difference. Same kind of thing here. If you can look at an equation and say which side has more x's on it and how many more, notice that, 16 on the left, 12 on the right, 16 is 4 more than 12. And that's what we got when we subtracted 12 x's from both sides. We got positive 4 on that left side. Okay? So thinking about it in terms of that can kind of help make that first step mental and kind of make sense of where you're going to move your variable terms. Let's take a look at the second one and kind of start with that game score thought process. We've got negative 8 ends on the left and negative 5 ends on the right. What's greater, negative 8 or negative 5? Negative 5. So we have more ends on the right side. How much greater is negative 5 than negative 8? How many more ends? 3. So this would be okay to realize, hey, I've got 3 more ends on the right side. I'm just going to write that as 9 equals 3n minus 18. Right? Mathematically, what we did here if you're like, wait, what just happened? Mathematically is we took these negative 8 n's and we added them to both sides. Negative 8 plus 8 is 0. Those cancel out. Negative 5 plus 8 is positive 3. Okay? But logically, if you can kind of recognize which side you've got more n's on and how many more, you can use that to help get this two-step equation. Okay? But if that's not clicking, then we've got the mathematical way too, opposite operations. Either way, at this point, now we're going to add 18 to both sides. So I got 27 equals 3 times n. Divide both sides by 3. And our variable is 9. Okay? Feel all right? The third one is a little bit different than the first two that we've talked about. What is different about the third and the fourth one, but starting with the third one here, what's different about that third one? Go ahead, Lily.
It's the same amount of variables on each side.
Yeah. What do we do then? Because what's going to happen when we start to move variable terms around if we have the same number on both sides, Kate? They're going to cancel out on both sides. You know, if I've got 9 on the left and 9 on the right, that's like a tie. That's the same as being 0-0, isn't it? If I subtract 9 y's from the left and 9 y's from the right, everything cancels out. And what I'm left with is negative 12 equals 18. Good question. Is that true, Linnea? Yeah, all those times when your teachers told you growing up, there's always an answer. There's not always an answer. Okay? There is no solution to this. There is no possible value for y that you could plug in to make this equation true. Because if 9 times y is the same thing, on one side you're subtracting 12, on the other side you're adding 18. Those are never going to be equal. So this is a situation, there we go, where there is no solution. And the symbol for that is a 0 with a line through it. There's no possible way to make this equation balanced. What's that? The next one's similar, but what do we get? Recognizing that these n's are going to cancel out because of the same number. Again, what we're talking about here is when we have the same number of variables on both sides, what are we left with? Caroline, what are we left with on the left side here when we take out those 8 n's? 2 and 5, which makes 7. On the right side, we have 7. Is that true? So what does that mean?
I know. It's 7. You can plug in anything you want and it'll still be the same.
Exactly. You can plug in any number you want for n, and it's going to work every single time because the two sides of the equation are exactly the same. You're multiplying n by 8 and then adding 7. There's no way to make them not the same, right? And so in this case, you have infinite solutions. Infinite solutions. And the symbol for that, you start with like an 11. And then from the first line here, kind of make an R. That stands for all real numbers or all real solutions. Anything you could plug in there is going to make it work. What?
What about imaginary numbers?
Well, imaginary numbers aren't real. So that would be where that line is drawn. Imaginary numbers are, I think we've talked about this before a little bit, but if you take the square root of 9, we know that is 3, right? Because 3 times itself equals 9. So then during math class one day, one smart aleck kid raised his hand and said, well, what about the square root of negative 9? Right? That's a problem because 3 times 3 isn't negative 9. Negative 3 times negative 3 isn't negative 9. The only way to get -9 is 3 times -3, but that's a problem because that's not something times itself, right? So then all the math teachers met at like a Perkins or something, and they figured out, what are we going to do about this? And Alan?
Absolute value of 9.
No. The solution is 3i, and that little I stands for imaginary, where they're saying, if this existed, it would be 3, but it really doesn't, so we're just imagining that it does. And now we can answer Smart Alex Kid's question and move on with our lives. Okay?
Absolute value of -9.
No.
What?
Okay? So that's where imaginary numbers come in. Okay? But that R is for all real numbers here. Okay, so basically the moral of the story here is the 3 types of variable on both sides equations that you'll see. One type will have a different number of variables on each side, in which case you can solve it. Okay. The other type will have the same number of variables on each side. If after canceling them out you get an untrue equation, it's no solution. If after canceling them out you get a true equation, it's infinite solutions. Okay. Most of what you'll come across will fall in this first category. We can actually solve it, but those other 2 do exist. So let's go back to the page where you had your homework. And we had second row here, this first one, 5p minus 14 equals 8p plus 4. We're going to go over a couple together, and we'll see how far we get. Okay. The other class had no equation left unsolved as their homework, so they had to do everything. I don't know if we'll get that far, so we'll just kind of see. But anyway, 5p minus 14 equals 8p plus 4. Taking a look at this equation, we know there's going to be a solution because we've got a different number of p's on each side. Which side has more, and how many more? The right side has 3 more. So it'd be okay to directly jump to -14 equals 3p plus 4, because the right side has 3 more. Whether it's 5 and 8 or 0 and 3 doesn't make a difference. 3 more is 3 more. Mathematically, what we're doing here is we're subtracting 5p from both sides to actually cancel it out, right? 5p minus 5p is 0, and then 8p minus 5p gives us that positive 3 there. But now we're at our 2-step equations to solve. This is the new part of 2-step or of solving variables on both sides. So if you have a question on how does he get from this to this, because it's just one thing I did, but getting from the original equation down in this 2-step, please ask a question, because that's the skill being practiced today. Christopher. Yes, we'll do several of them. So now, yes, Camden.
Do we need to show our work is corrected?
Show your work and then check the answer. Yep. Remember that on a test, I do not require work shown, but that's when you get to show me that you can do it however you choose to do it. But for this, I would like to see this skill practice and this work shown. Okay. If you want to skip this step, this first step, because you kind of wrap your head around that 3 more concept, or which side and how many more, you can skip that step, but then I need to see the rest of the work. Right? So subtract 4 from both sides, we get -18 equals 3p. Divide both sides by 3, and p equals -6. Okay. The next one, 12p minus 4 equals 7 plus p. Which side has more and how many? Which side has more and how many, Alan?
The one with the 4 sides on the left and 12?
Not 12 more.
11 more.
It's that darn 1. Okay? This is 1p that we have there. Even though the number's not written, okay, it's a coefficient of 1. So we're comparing 12 to 1. So that's the same as saying we've got 11 more on the left side. Okay? Of course, mathematically, again, opposite operations, subtract 1p from both sides. 12 minus 1 is 11. And on the right side, they cancel out. Okay. Add 4 to both sides. 11p equals 11. Divide by 11, and it equals 1. Okay. I heard a wait what. Was that directed at what we're doing? Someone have a question? No? Okay. Does that wrap up the page then? Is everything? Did we do everything on this first page now?
There's one.
There's more.
There's one right above it. Right above it.
Right above it? I missed one?
There's 3 more. Scroll above those.
There's 2 above
Yeah,
the one that we just did,
one on
and
the
then one
top
up on the
row.
right side.
Oh, I did skip a row. My fault. Okay. So the next one here, a plus 5 equals negative 5a plus 17.
No, another row above it.
Well, you should have done all those though. Those were homework for today.
Not the top row on the right, very right. Yeah, the very right was homework.
Valid point. Valid point. Valid point. All right. So pick one of the remaining 3 on this page to do together. We have the third one in the first row, or either of these 2 in the second row. Who wants to make the decision for the class on which one we do together? Camden.
Second in the second row.
The 4M?
Yeah.
All right. What do we know about this particular setup? Luke?
On the 4M and 4M are the same thing.
We've got the same number of M's on each side.
But there's a problem with this because the 4M on the right side of the side doesn't have -4 to go with it.
Okay, so we know that they're going to cancel out because that's what happens when you have the same number of variables on each side, right? Just like in the 2 examples we saw on the first page. This is one of those special types. 4 times m is going to be the same thing. If you subtract 4m from both sides, you'll get 0m. So on the left side, we're left with -4. What's left on the right side? 0. Not a 1, 0. Okay? If there was a 1 left, there would be a +1 afterward, right? So is this true? It is not. So no solution. Okay? No solution. The next page, there is a second page to PO10 Part 2. If equation solving were like the Mushroom Kingdom, these would be the Bowser equations. Okay? These are the equations that truly test your understanding that if you can solve these, you can just go home.
You
Okay?
can beat Rainbow Road.
So on the second page,
You can beat these. You can beat Rainbow Road without falling off.
right.
I can already do that.
On the second page here, one of these first 4, pick one you'd like to do together. Who'd like to speak for the class?
First one.
Olivia.
Last one.
The third one? There's 2 times 4x. Okay.
No,
Hey, folks, we'll get there. Just calm down. Just hold
The
on.
last one.
Just hold on. Just-
Last one. Got a little bit too much dip on your chip.
you have to beat Boom Boom before you get to Bowser. Yeah. All right. So what makes the equations on this page kind of that added challenge is that there were 3 different types of multi-step that we talked about: combining like terms, distributive property, variables on both sides. These equations all have more than one of those things, right? If we look at this equation here, I see parentheses, which means I'm going to have to distribute, and I see I've got x's on both sides. So the only extra challenge here is you have to deal with more than one type of multi-step, like a multi-step. Okay. We're going to start with parentheses. 2 times 4x is 8x. 2 times -3 is -6. Of course, I don't distribute to the -8 because that's outside of the parentheses, right? So that's just -8 equals 4 plus 2x. So my first step was just to get rid of the parentheses by distributing in the 2 to everything inside of the parentheses. Nothing else changes. Of course, I'm looking at this now and I'm realizing this is the trifecta, right? Because we distributed. What do we have to do now? Combine like terms, and then we've got to deal with the variables on both sides. So it turns out this is the Bowser. Okay. -6 minus 8 gives us what? Negative something is close, but -14 is closer. Okay.
Both are accurate.
Both are accurate as well, yeah. So 8x minus 14 equals 4 plus 2x. Okay. Now that we've simplified both sides of the equation, there really wasn't anything we can do with the right side, but that left side has some stuff. Okay. Now that we've done that, now we just got variables on both sides. Which side has more x's and how many more? Luke.
The left side has more x's and it has 6 more.
Exactly. So we can write this to be 6x minus 14 equals 4. Mathematically, what we did to get that 6x was we subtracted 2x from both sides. To cancel it out, on the right side, 2x minus 2x gives us 0. And then 8x minus 2x is where that 6x came from there. It looks worse than it is.
Yeah, and especially when you get it out.
It's just doing the steps.
And after this, it's really easy.
It's just doing the steps. And now we're at our comfort zone, right?
Yeah.
That two-step equation.
It comes out clean numbers, so.
They don't all come out clean. We'll do one that doesn't come out clean.
No, but this.
McKenna.
So when we check it, do we do the distributive?
Yeah, so let's just solve this out. So we get 6x equals 18. You should get 3 as an answer here. Okay? And to check this, this is why we've got calculators. This is why you can use a calculator on your homework and on this upcoming test. Go back to the original equation, and wherever there's an x, plug in 3, right? Just that exactly in your calculator. That gives us 10. Remember that. Go to the other side of the equation, plug that in, and you get the same thing. As long as both sides of the equation equal the same thing, you know that you're right. Okay? All right. I would like to make sure that we cover this one. So on the time that we've got left, let's go to the last one here. Okay, this is another trifecta. We've got the parentheses, we've got combining like terms, and you see we've got variables on both sides. So we're going to start with parentheses. Folks, distribute the 5 in. 5 times negative 8 is negative 40. 5 times negative 2, negative 10. The left side's done now. Right? All we had to do was distribute. On the right side, all we've got to do is combine these like terms here. Negative 4x minus 8x, negative 12. Okay? The reason why it's negative 12, we're not using opposite operations here. We're not moving them from one side to the other. We are just combining them. Negative 4 minus 8 gives us negative 12. Now for variables on both sides, this one, figuring out how many more and which side is a little bit more complicated because we got the negatives in there. So the mathematical way, just add 12x to both sides, cancel them out. Negative 12 plus 12 is 0. Negative 40 plus 12 is? Negative 28. Minus 10 equals 16. Oh, Bowser, you rascal. You scoundrel. Why do I say that? This is not going to come out very cleanly. So we're going to add 10. We're at our two-step equation here, so trust the process. Add 10 to both sides. Negative 28 equals 26. 16 plus 10. Divide both sides by negative 28, just like we would if this would work out evenly, just because it doesn't. I mean, fractions, decimals, they're a part of math. Okay, hold on.
9, 2, 8, 5, 7, 1, 4, 2.
So hold on. No, that's just before you start freaking out. Okay, remember, Caroline and others, remember, Colin and Matthew, remember that a fraction is just division, right? Or division is just a fraction. 26 divided by negative 28 isn't any fun to look at in a calculator, but as a fraction, 26/28, what does that simplify down to be?
0.9.
Not 6/7,
Negative 0.928.
not 8/9.
Negative 13 over 14.
Negative 13/14. Okay? Negative 13/14. Now, if you did write the decimal answer, that's okay. Just round it to the nearest hundredth. Right? To check this answer, you've got a couple different options. Last class, this was kind of new to them. Those of you that have calculators, if I may borrow, that look like this, which most of you probably do, whether it's green or pink or black or blue or whatever. Up above the 7, 3 buttons up, there's this ABC button. That's your fraction button. When you press it, it gives you something. Does it look like that? Okay. So how you'd check this is you'd go back and you'd say 5. This is what goes in your calculator. Now 5, parenthesis, negative 8 times negative 13. Then you'd press that ABC button to get that symbol. Then 14. Then minus 2 and close your parentheses. Okay? And I believe if you do that correctly, you get 27, then this U, and then 1/7. Okay? What does that U mean?
You matter.
Hold on, folks. So going back to this here, what does that U mean? When your calculator gives you that answer, what does that mean? Anyone know? Nick? What? I thought you said your face. Like, whoa, the burn. It's a space, but tell me more. Right. This is your calculator's way of showing you it's a mixed number, 27 and 1/7. Okay. It can't write 27 and 1/7 like that, because then you might think it's 271/7. Right. So it's got to put that space there to let you know. But how you check a fraction is by using that ABC button. Your other option is to take the decimal value and round it and plug it back in. Just keep in mind that your two sides might not be exactly equal if you're using a rounded value. Like we talked about before, whenever you round, you lose some accuracy. So just be aware of that. Your two sides might be close. They might not be exactly equal. Okay, your assignment for Monday is to, just like we leave no trolls left behind, leave no equation left unsolved. You got like the first page all done and 2 of them on this page. You got 5 days to do it. It is due on Monday. If you have questions over the weekend, you know how to get a hold of me. All I'll be doing is playing Mario Maker and eating tacos. So I will have no excuse not to answer you. Camden.
On the first page too, there's top right one.
Yes, the top, the first page and the second page. Christopher.
Does it matter which side you
Folks.
like for the negative 40x? Does it matter if you take equal 40x?
You add 40x both sides?
Does it matter?
No. You'll get the same value. Noah.
So wait. What was I gonna ask?
You guys have your face.
No,
Your face.
when are the week like?
That wasn't
Like,
needed.
it's 5
Your own
standings.
Griff. Matthew.
When are the standings gonna go?
Oh, they'll be posted in Google Classroom. All right, that's how you math.